Hello everyone, let's continue with our linear programming. So we're going to actually write the constraints from some context. This is a word problem. Before I do the one with the creating the constraints, let's do the second one here. Doesn't have any of the word problems to it, so we'll just kind of review the process. First of all, these are called the constraints, and these are what we're going to graph, and this is called the objective function. You do not graph the objective function. You only use that at the end once you have the vertices. So if I have the constraints, the first thing I'm going to do is graph the constraints, and I'll do that in Desmos because we have Desmos, so we're going to use Desmos. X is greater than or equal to 0, and y is greater than or equal to 0, which these are very common constraints. This is basically just saying you have to do positive things. Okay, you're not going to lose anything. Nothing's going to be negative in this problem. And my other constraints are 3x plus 4y is less than or equal to 20. Okay. And the last one, 2x minus y is less than or equal to 6. So what we are looking for is the overlap between these, and what I'm trying to find specifically are the vertices. So you got to kind of play around with it sometimes to figure out where this is. I'll get rid of these two and say, okay, x is greater than 0, so we're going to the right, and then y is greater than 0, we're going up. So we're only in the first quadrant here. And then 3x plus y is less than or equal to 20. So notice that's being shaded down towards the origin. And this one is also being shaded towards the origin. So the overlap is right here. And the first thing you want to do is draw those vertices, because those are the vertices of what we call the feasible region. So I'll just draw this here. This is all in the first quadrant. The first thing you need to do is find the vertices of the overlap. We call that the feasible region. It's right here. This is called the feasible region. Now, you can test any ordered pair in here, and it will satisfy all four of these inequalities. But linear programming has a theorem that tells you the maximum and the minimum will always come from one of these vertices. So now that we have the vertices, we're going to plug them into the objective function. So 2 times x plus 4 times y, and we'll see what we get. There's 4 vertices, so I need to do this 4 times. Okay, so I'm just plugging into the objective function the x and the y coordinates. So 0, 5, 4, 2, 0, 0, 3, 0. Doesn't matter what order you do them in. That would be 0 plus 20, so 20. 8 plus 8 is 16. 0 plus 0 is 0, and 6. So what we've done is we have tested the objective function, and now if I want to say find the maximum and the minimum values, the maximum value right here is 20. So if you want to maximize it, this is the maximum. So the max is 20. And then the minimum, the smallest one, is 0 right here. This is the min is 0. And again, it's very common that the minimum is 0. You should hopefully take from this, if you do nothing, you will make no profit. If you do nothing, you're not going to accomplish a whole lot in anything you're doing. So this makes sense to me. If you do nothing, you will get nothing. So if 0, 0 is an option, it's usually the minimum. So that's the process. You graph the constraints, you find the feasible region, you identify the vertices, and then you test them in the objective function. This problem, we have to create the constraints. So let's see what we've got here. We're buying pizza for the Super Bowl party. If you buy at least 4 of each type of pizza, so if you buy at least 4, then you get a reduced cost. Let's say X is the number of, what are my options? Cheese? Oh yeah, right here. This is X, and Y is the number of pepperoni. Okay, you can see the label, the X and Y axis are already labeled for us. So I know my variables are number of cheese pizzas sold and number of pepperoni pizzas sold. If it says at least 4 of each type, X has to be greater than or equal to 4, and Y has to be greater than or equal to 4. So those are our first 2 constraints. You have to order 4 of each type of pizza to get this deal. Now, the other constraint is usually something about how much money you have. You can't just buy infinite pizza unless you have infinite dollars. In this problem, we don't. Cheese pizzas cost $4, pepperoni pizzas cost $8, and you have $80 to spend. So this should feel familiar. We're going to say 4x plus 8y. Now, you don't have to spend all of your money, so we'll say less than or equal to $80. You might say, you know what, we don't need to buy all $80 worth of pizza. Let's just buy $75 or whatever it is. Okay? Those are our only constraints. You had to buy 4 of each. and you have a financial constraint. So I'm going to use Desmos to graph this. I'll erase this one. X is greater than or equal to 4, y is greater than or equal to 4, and then the other one is 4x plus 8y, and again, you don't have to spend all your money, so you can say less than or equal to $80. So let's find the overlap. To the right of this line, above this line, and below this line, so it looks like it's this triangle right here. That is the feasible region. So what you really need to draw in your graph is the feasible region, because those are the points that you care about. Okay, and you can actually put the dots, because since I have this labeled, 12, 4 is right here, 4, 8 is right here, and 4, 4 is right there. That's what I care about. That's the feasible region. Okay? Now, I have an objective function. Well, I don't have an objective function yet. So I'll just put this right here. Ooh, that's pretty cool. I like it. All right. The objective function is what we're trying to maximize pizza enjoyment. Okay, so my objective function, usually we say C or P for the objective function, P if it's profit, but I'll use C because it's not. 3 people prefer cheese. So for every cheese pizza I own, I make 3 people happy. 5 people prefer pepperoni. So for every pepperoni pizza, I make 5 people happy. And this is going to help us figure out how do we make people happy? The most amount of people happy. What combination of pizzas should we order? So it's 3x plus 5y will give us our potential objective function values. And we'll see which one's the biggest and the smallest. So if I do 4, 8, 12 plus 40 is 52. If I do 4, 4, 12 plus 20 is 32. And if I do 12, 4, 36 plus 20, I get 56. So if I want to make the most people happy, I should get 12 cheese pizzas and 4 pepperoni pizzas. 12 cheese and 4 pepperoni gives us a happiness score of 56. Okay, that's the best you can do. Okay, you can't make everybody happy, but if you total them all up, buying that combination of pizzas will make the most amount of people happy. So 12 cheese pizzas and 4 pepperoni pizzas. So you create the constraints so that you can graph them, you create the objective function, and then you test the vertices. Let's try another one. Now this one I'm going to do all in Desmos, so I don't really have a whole lot of work here. So first, we got x is the number of bowls and y is the number of plates. I want to create my constraints. What are we doing here? We're making bowls and plates. A bowl uses 5 pounds of clay. A plate uses 5 pounds of clay. We have 40 pounds of clay. So 5x plus 4y has to be less than or equal to 40. You don't have to use all the clay, but you can't use more than 40. What's my other constraint? At least 4 bowls. So the number of bowls, what's variable for bowls? X has to be greater than or equal to 4. Okay, I think if you had to add one extra constraint, we don't know anything about plates. Let's say it's got to be positive though. You're not, or it can't be negative. It can be 0. But you're not going to like go around breaking plates to make money. So you're not going to have negative plates made. So just say it's greater than or equal to 0 to help you with your Desmos. So now in Desmos, I've got my constraints. Let's graph the constraints. 5x plus 4y is less than or equal to 40. X is greater than or equal to 4. And then just for good measure, we'll say y is greater than or equal to 0 so we can see the overlap. So the overlap is, let's see, okay, we're above the y-axis, we're to the right of 4, and then it's right here. Okay, so I'll screenshot this so I don't have to keep flipping. All right, so the objective function is not yet written, but we have the vertices that we're going to test in the objective function. Those are the corners of the feasible region. Now let's talk about maximizing profit. Okay, how much money do you make for each of these? I'll say P for profit. 35 per bowl, so 35x, and 30 per plate, so 30y. So now I have an objective function, and I have the vertices. I just need to test them. 35x plus 30y. I need to test 3 different vertices. So 35 times 4, I'll do it in a different color, I like it. 4, 5, 4, 0, Just to be safe, let's use a calculator. I think I can probably do this, but I don't want to mess it up on YouTube, so we'll make sure we do it right. Okay. 140 and 150. I think it should be 290 plus 30 times 5. 290. Sweet. We got 290 for one of them. Now that's $290 profit. 4 times 35 is 140. If you make 4 of the bowls, you will make $140 profit. If you make 8 of the bowls, hopefully it makes sense you're going to make a lot more money. You would make $280. Okay, so just to be sure, 35 times 8. Yeah, good. So how do you maximize profit? Turns out the most you can do is 290. So you should make 4 bowls and 5 plates to maximize profit. The way you would maximize profit, the amount of money you would make is $290. The most amount of money you can make here with those constraints is $290. And that's what we're trying to do, is make the most money, trying to profit. Okay, so if you think any business, you're going to have some constraints. You don't have infinite of anything. So you have to consider, how do I play this game so that I maximize profit? In this case, make 4 bowls and 5 plates, and you will make $290.